If I asked you to graph it, I would say everything from $20 on down would be true, right? Could you buy a shirt for $1? Yes, you can, because it is less than or equal to 20 bucks. Or maybe I'm a shirt snob and I only want to buy fancy shirts. And I want to only buy shirts that are costing more than 50 bucks because I'm a shirt snob. If I only want them to be more than $50, can it be $50? No. I said greater than $50. So that means to graph it, I put an open circle over the 50 because it doesn't include 50. Or maybe us gals want to lose weight. As a matter of fact, I want my weight, E-I-G-H-T, never to exceed 130 pounds. I didn't write it using a less than or greater than symbol. Less than or equal to, greater than or equal to. How will I explain that I do not want my weight to exceed 130 pounds using less than, greater than, less than or equal to, greater than or equal to? Go. Okay, but that means it can be 131. But I said, no, it cannot exceed this. Emma. Which symbol? No, yeah, tell me. If it cannot exceed 130, then what must it always be? Less than, good. Less than, exactly right. So that would be never equal to, only less than. Obviously, there's a reasonable distance that it can go before I become dead, but in any case, that would be a fair example. And boys, I know there's a certain, maybe, I don't know if have any of you ever been wrestlers in here? Okay, when I was a kid, almost all of my classmates were in the local town wrestling team. Anyways, the boys wanted also to have their weight kept at a certain place so that they can wrestle at a certain weight limit, so that would apply to them as well. Maybe your earnings, you want to earn a certain amount of money. Earnings cannot fall below $45,000 a year. Notice I did not use a less than, greater than, less than or equal to, or greater than or equal to symbol there. But how would I describe my earnings using any of those symbols? Earnings have to be greater than or equal to. Why? Because it says it can't fall below this. It can be this based on this sentence or this statement, but it cannot fall below. And if I were to graph it, kind of got a little crazy, 45, 50 in thousands, you would put a closed circle because it does include 45,000, and then on up. So to summarize, less thans and greater thans when they're graphed will be open circles. And then you will shade whichever way you need to go. Right if it's bigger, left if it's smaller. Less than or equal to and greater than or equal to are going to be shaded closed circles. And then shade right or left accordingly. This whole open and closed circle is a huge, huge issue that I find. So pay attention to this right now. Do you guys get all this for now? What if I said to you, water freezes at 32 degrees Fahrenheit. Yep. Indicate an inequality. It's not exactly like the one in the book, so don't look in there. Stating when water isn't frozen. So it freezes at 32, which means 31, 30, 29. It continues to stay frozen, right? When does it thaw? It thaws when it is greater than what? Emma? 32. Good. So greater than 32 is when it thaws. I'm being real cheap with my graph there. Open circle, because at 32 it'll be frozen, but anything over 32 it starts to thaw. And then everything to the right, it is not frozen. That happens to be very similar to their example 1, which deals with Celsius and freezing, different things like that. Now, example 2, I'm going to go ahead and flip here in just a second. Example 2 has us starting to solve inequalities that have variables in them. Solve and graph. In order to answer this, what must you do? There's two things. You have to do something and something else. Rhino, what must you do? You must something and something else. What are the two things? Yep. And what if you don't graph it? Is it still right? No. Why? Because it says and, right? Remember how I said back in a couple lessons back, it said check? Strangely enough, this particular assignment doesn't have checks, but it has, well actually today's assignment does, but tomorrow's doesn't. It has graphs. Today's assignment says solve, graph, and check. Okay, 3 components. How many components? 3 components. So Ben, you're going to have to do what 3 things for today's assignment where it says so? Yep. And that's only for items 7, 8, 9, and 10 of today's assignment. But for example 2, it says solve and graph. And here is my example 2. Okay, added to 12. Riley, what you got there? Let me see what you got so far. K plus 12 is less than or equal to, go ahead and set it down. You can move your hand. Thank you. Is less than or equal to -4. Do you guys remember an equation like this might look like this? K plus 12 equals -4. Notice the only difference here. This is an equation. This is an inequality. Lucky for us, the steps do not change. We've got addition going on here. We're going to inverse operation. We're going to do the opposite. Just like we would over here. By subtracting 12, we now have K. K is not equal to, K is less than or equal to -16. Less than or equal to -16. Just like the equation has the same numeric value, but since it's an equation, it's equal to. Do you guys see the difference here? The only change is that. Okay? We're going to graph it next. -16 less than or equal to. So it's a solid circle. Notice I haven't graphed to the right or left. I haven't written numbers. This is smaller. This is greater, bigger. So what number goes to the left indicating smaller still? What number goes next? Ben, what do you think? -15 is actually larger. The closer you get to 0, the bigger you get. Say again? Yep, -14 is still bigger. Yep, the closer you get to 0, the bigger you get. Good, -17. Now, which way am I going to shade? Left or right? Left or right? Sarah? Left, because it is less than or equal to. Less than or equal to. That's example 2. Notice how it's the business side and the answer on the right. The business side and the answer on the right. It doesn't matter if it's the other way. Example 3 simply shows it the other way, but doing the exact same stuff. Here's example 3. -1 is greater than y minus 7. I could even say it as an equation, but again, this is what we've already learned, but I want you to see how similar it is. This is an inequality. This is an equation. We're going to do the inverse, which is going to be to do what with the 7? Leah, what are we going to do with the 7? Yep. And just for fun, I'll show it to you here as well. Cancel, cancel. So 6 is greater than y. 6 equals y on this side. Okay, let's look at this for a minute. If 6 is greater than y, then y is what in relationship to 6? Y is what, Noah?
Less than 6.
Yes. For me, stating that 6 is greater than y is annoying. I hate having the variable on the right. And it's also kind of easy to twist when you graph it. So take this thing and flip it over. The y from the right moves to the left. And notice the little pointy piece, how it was facing the y. Well, the little pointy piece still faces the y. Y is less than 6. Yes, ma'am?
So do we have to do that on our homework?
I don't really care how if you flip it like this. I just do it for me.
Okay.
But to graph it, it's important that you recognize 6, 5, 4. We're talking about y, and y is everything smaller than a 6. Why am I using an open circle, Mr. Chris, and not a closed circle? Because it's not equal to. Good. The only time it's shaded is if it is also equal to. Yes, Rach?
If you did the equation, like put 6 for y, it'd be -1 is greater than -1. That doesn't make any sense. The 6 minus 7 is
Right, it's anything smaller than 6. Which brings up a great question. It's not going to be 6. It's anything smaller than 6. So in order to test it, you have to pick something smaller than 6. Awesome, awesome point. Anything.
So for the answers, what do we write?
This is your answer. This is your graph. And if you were to check it, you would have to choose a number that satisfies this. Say 5. So 5, for example, -1 is greater than 5 minus 7. -1 is greater than -2. True. Emma.
So there's not like an answer for y?
Well, there is. Anything less than 6. Because these are inequalities. This is where people start to get bound up. You're asking great questions. It's not y is always like equal to something. It is now y is smaller than this number, which means it can be an infinite number of answers as long as it's smaller than the 6. Yeah. You guys are hitting all the great questions. That's example 3. All right. Example 4. I want you to look at the triathlon example right out of your textbook. If you have it in front of you, if you have it on your lap, look at it. I'm going to utilize that one. You are competing in a triathlon, which is a sports competition of 3 events. Last year, you finished it in 85 minutes. To the right, the table shows the times for this year's first 2 events. Swimming, and this is in minutes. The second portion of the event was done in 45 minutes. The last portion of the event is the run. What possible times can you post in the running event and still beat last year's finishing time? In other words, do better than. In order to do better than last year's finishing time, do you want to do it in more than 85 minutes? Remember, this is a race. Or less than, Jewel. Bravo. So you want the sum of these 3 items to be less than, shoot, what was it? 85 minutes? So the swim added to the bike added to whatever we come up with for run needs to be something smaller than 85 minutes. What do I do with the 17 and the 45? What do you guys think I do? Miss Hope, what do you think I do with these two numbers? Yeah, combine your like terms. You'll end up with 62. So the 62 minutes of that portion added to his run time needs to somehow add up to be something smaller than 85 minutes. What do I do next, Stu?
You do 85 minus 62.
Bravo. Good. You are left with the fact that his run has to be smaller than 23 minutes. Anything smaller than 23 minutes, 22:59. And this guy will have done better than the previous year's time. Anything smaller than 23 minutes, and the guy will have done better. If you're asked to graph it, 21, 22, 23, 24. Open circle or closed circle? Ethan. Shade left or right, Ethan? Good, smaller. Obviously, there comes a point when the number doesn't even make sense. Like if you say, well, what if he does it in 1 minute? Well, if he does it in 1 minute, he's the Flash, and we have a whole new set of issues on our hands, okay? So logic would dictate that we're just hoping to get something right around here, as long as he's below that number.